We've pretty much been told that physics is close to finishing the job. One final theory and everything will make sense. But that doesn't quite seem to hold up, because the deeper we go, the more the foundations split apart. Gravity doesn't fit in. Quantum theory doesn't align. The closer we get, the less it agrees. So here's the real question. What if the universe isn't waiting to be unified, because it was never one thing to begin with? Physics, Consciousness and Reality. Dickie Dredd and Nigel Adams. And this is part 10 in the video series. We're still in chapter 1, the hard science, and this is the last part of chapter 1. We'll move on to chapter 2 after this. So, part 7, section 7 in the book, The Hunt for a Theory of Everything, Unifying Gravity. The Standard Model, and we discussed that in the previous video, is a masterpiece, no doubt about it. There's an elephant in the room, gravity. The everyday force that keeps us on the ground, shapes planets, drives stars, and sculpts galaxies, doesn't fit into the picture. The Standard Model runs on quantum rules, while gravity is described by Einstein's smoothed, curved space-time. The two speak different languages, and ever since Einstein's days, physicists have been chasing the dream of unifying them, the so-called theory of everything, or TOE. The most famous attempt is string theory. Instead of treating particles as point-like dots, string theory imagines them as tiny, and we mean tiny, far smaller than an electron, vibrating strings. Different vibrations give rise to different particles, like guitar strings playing different notes. It's a beautiful idea, and it promised to include gravity naturally. For a while, it was the big hope, thousands of papers, careers built on it. But the cracks showed. The maths demands extra dimensions, not just 4, 3 of space and 1 of time, but 10, 11, or even more. And worse, string theory doesn't give a single prediction that can be tested. Not one. It produces a vast landscape of possible universes, billions of them, with no way to pick which one is ours. For many, it's fizzled out. Elegant, yes. Useful, maybe not so much. Another contender is loop quantum gravity. While string theory tries to smooth everything into vibrating filaments, loop quantum gravity goes the other way and makes space-time itself granular. In this view, space is not a continuous fabric, but woven from tiny loops, discrete chunks of ultra-tiny scales like atoms of space. Time too may come in quanta. The mathematics of loop quantum gravity suggests that near black holes, or at the Big Bang, space-time would not collapse into a singularity, but bounce, avoiding infinities. It doesn't try to unify all forces, but it does offer a direct attempt to quantize gravity itself without adding extra dimensions. The downside? Like string theory, testable predictions are thin on the ground, though some hope that traces might appear in the cosmic microwave background or in the behaviour of black holes, and we'll do an appendix on black holes soon. For now, it remains a bold but unproven sketch. Then came more exotic takes. Garrett Lacey, a surfer physicist, pitched his E8 theory, a grand unification based on one of the most complex symmetrical structures in mathematics. The E8 shape is like a fantastical 248-dimensional jewel, and Lacey proposed that all particles and forces could be embedded in it. The media loved the story, a maverick with a whiteboard in a van, taking on the big guns, but the details didn't hold. Critics showed that E8 couldn't quite accommodate the known particle families without breaking its own internal rules. A bold vision, but probably not the answer. Then there's geometric unity, put forward by outspoken Eric Weinstein. He claimed to have a new framework, a hidden geometry underlying the Standard Model and gravity alike. It stirred a storm because it was announced outside traditional channels, not peer-reviewed papers but podcasts and talks. Some dismissed him outright for that reason. Others were intrigued. The problem is, without proper publication and scrutiny, it remains more of a tantalising sketch than a tested theory. Then there's Stephen Wolfram, the software and maths prodigy, who thinks the universe itself might be built from simple computational rules. Instead of continuous space-time, he pictures a giant hypergraph, a network of nodes and links updating step by step, like a cosmic computer program. Out of this, he claims, space-time, quantum mechanics and even relativity could all emerge. He even claims to solve the observer problem and the concept of entropy, and again we'll do a appendix on that soon. It's a wild idea, somewhere between physics and computer science. Critics say it's too vague, too self-promotional, and again, not tied down to experimental predictions. But it's another sign that people are thinking outside the usual boxes. So where does that leave us? After decades of searching, there's still no theory of everything. String theory dazzled but stalled. Loop quantum gravity offers a compelling picture of granular space-time but remains speculative. E8 and geometric unity haven't delivered. Wolfram's approach is bold but unproven. The truth is, we can explain almost everything we see in the universe, yet the foundations still don't line up. And yet, despite the stalemate, some physicists argue we may be closer than ever. The Standard Model has been experimentally confirmed to extraordinary precision. Gravitational waves have now been detected directly, and black holes images have moved from theory to photograph. Advances in quantum field theory, holography, and the study of quantum information have uncovered deep links between gravity, entropy, and space-time geometry. Hints that space-time itself might emerge from quantum entanglement. Some mathematically abstract concepts show that gravity in certain universes can be equivalent to a quantum theory without gravity on a boundary. To optimists, these are not random fragments but converging clues. The pieces look messy, but perhaps they're edging towards coherence. The fact that so many independent approaches keep circling geometry, information and emergence suggests that the target may be coming into focus. Others are far more sceptical. They argue that a theory of everything may be a mirage, not because reality lacks unity, but because our methods may never reach the required scales. The Planck length, I'll tell you what that is in a minute, is so unimaginably small that direct experiments may forever be out of reach. Some suggest that physics may be approaching a fundamental epistemic limit. We can model what is observable, but the ultimate layer may remain permanently beyond empirical test. There is also a philosophical worry that the very idea of a single final equation is a relic of Enlightenment optimism, projecting human neatness onto a universe that may be irreducibly plural. In this view, unification could be like the horizon. The closer we think we are, the more it recedes. Maybe the final theory won't look like physics at all. Maybe the missing piece isn't another particle or a new symmetry, but a shift in perspective. What if the real ground of reality isn't space-time or fields, but consciousness itself? That's where we may be heading. So a quick take on what the Planck length is. So Planck length is thought to be the smallest meaningful unit of length in physics. It's approximately 1 times 10 to the minus 35 meters. That's 1.6 with 0.3516 meters. So it's really small. It's much smaller than even electrons, below which conventional ideas of space and distance may longer apply. It represents a scale at which quantum effects of gravity are expected to become significant. So what this section really shows is that the hunt for a single unified theory keeps breaking against the limits of our own frameworks. And if that's true, then reality may not be something that can be reduced to one clean equation at all, which means the problem isn't just finding the right theory. It might be the assumption that reality has to fit inside one. And if that's the case, what exactly are we trying to unify? The universe or our need for it to make sense? Next up, we move on to Chapter 2, and I'll describe what's in Chapter 2 in a minute. I'll summarise this chapter in a minute. Chapter 2, Beyond Physics, Mind, Evolution and Perception. And we'll start with Part 8, which is Space-Time is Dead, Emergent Reality and Hidden Structures. So, just to give you a summary of this first chapter. The first chapter has traced the outlines of the sciences that describe the physical universe. We explored the foundations of physics, chemistry and biology, and the methods by which they build knowledge. The picture is powerful. From subatomic particles to galaxies, from molecules to ecosystems, science reveals order and law beneath apparent complexity. Yet alongside its successes, we saw its limits. Equations can model matter and energy, but they do not exhaust the mystery of life or the enigma of awareness. The sciences give us an account of mechanism, structure and process. What they do not yet explain is why consciousness arises at all, why perception shapes the world we know, or how meaning emerges from matter. These questions demand that we go beyond purely physical. For this reason, the next chapter shifts the focus. Chapter 2 explores mind, evolution and perception, asking how consciousness fits within nature, how our senses filter reality, and how life itself may be more than physics extended. If Chapter 1 laid out the hard sciences, Chapter 2 begins the journey into what lies beyond it. And just as usual, information about the book. The book has been submitted. I've got the I know how much it's going to cost now, so it's just a matter of placing the order and working out exactly how I'm going to sell them, and you can all start buying your copy.